what exactly is exception handling? Okay. So in Java, exception actually is an object. So Java is an object-oriented programming language. So in fact, the exception, thread, all of these are actually an object. Okay. So in Java, exception itself is an object. And what it does is it describes the exceptional behavior. It describes the exceptional behavior like something that is not usual. So imagine your program is running. How would you know whether something unusual has happened in your program? So in that case, somebody kind of raises that exception, creates that exceptions, and make it available for you, or make it available to whomsoever are concerned about the exceptions. Okay, whomsoever part will get to know, it will get clarified. But what we should understand is the exceptional, if there is any exceptional behavior, they will get made available. Those exceptional behavior, your code will be made aware that okay, so and so exception has happened. Now whenever an exception condition arises, okay, so there is an object, okay, representing that exception that is created, okay, and it is thrown in the method that caused the error. I think it got cleared here itself. So whenever some unusual behavior happens, what will happen? The corresponding exception object will be created and thrown in the method that is causing the error, that has caused the error. Okay, so who does this part? Creation of exception object and um, throwing the error. We will again get things cleared as soon as we progress. Okay, but understand that whenever any exception happens, any unusual behavior happens, there will be someone who will actually raise that. A good programming language practice, if we follow, there will be someone who will actually raise those exceptions, and it will be thrown in the method which has caused the exception. Now, that method where the exception was thrown, it has two choices. It may choose to handle the exception or pass it on. I'm not worried about the exception, or I'm not familiar about the exception, so I'm gonna just throw it all. Okay, so it's like exception has only two choices. Either you handle or you pass it on, like you throw again or throw. Okay, so there are two scenarios that will happen with any exception object that is made available to the method which raised that exception. Is it clear so far? Yes. All right. Now, let's understand the exception handling basics. So, at some point, as I said, with exception object, it needs to be handled or it needs to be thrown. So you cannot like you cannot do something like okay, I want to do something else. Okay, that option is not available. Either you decide to handle it, or you decide to throw it or pass it on to the caller of your method, and then caller will decide okay what to do. If caller, again caller will have two choices, either handle or again it will pass it on. Again the caller of that caller will be handed over the exception object, and that's how this gets propagated. Okay, now at some point exception object that was created, it needs to be caught and processed. So there has to be someone who will actually catch it and actually process it. It cannot be that everybody decides to pass it on. It cannot happen. Okay, pass it on. Okay, so there has to be somebody who will be handling it. Okay, now only it has two options. Either your Java runtime. So okay, we are talking about the exceptions. So exceptions can be generated by either your Java runtime system or manually by your code or someone else code. Okay, so there are two possibilities who can create the exception object. So exception object can be created by the JVM, right? The Java runtime system, and sorry, or it can manually be created from your code. All right, clear? So we talked about that, okay? Uh, there will be, so whenever some unusual behavior happens, there will be someone, an object representing that exception will be created, and it will be thrown in the method that has caused the error. So we did that part, but what we are trying to understand is who created that exception, who can create the exception. So what it says is that it can be generated by either your Java runtime system or manually by your code. Anybody has questions? Any questions? Now, any questions? No, right? Okay. Now, any errors that violate the rule of the Java language or the constraint of the Java runtime, those exceptional behavior, only in those scenarios, Java runtime system will actually create an exception and made it available to the current executing method. Again, I will repeat. So if imagine, right? So imagine you have got a Java runtime system, your JVM, and within that your program is running. Those Java runtime system, those JVM has some constraints. They have boundaries, they have restrictions, they have limits. If any of the issue happens in those constraint in your environment where your code is executing, in that case, Java runtime system will throw an exception, throw an error, actually, we call it as error, and it will be made available to the currently executing methods. Okay. Now, in what all scenarios we can throw the exceptions manually from our code? So when we want to report some of the errors, right, condition to the caller of the method, then in that case, we should actually throw the exception. Okay, so we got understanding clear. It can be generated by Java runtime system. Java runtime system will generate if there is some language condition has been violated, there has been some constraint of the Java runtime has been violated, then that error will be generated by the Java runtime system. Okay, and it will be thrown to the current executing method. Clear? And when manually we should go and throw the error when we want some error condition to be made aware of our caller. So if imagine it's like whenever you write a method, you will get an input. What will happen if something goes wrong while processing in your method? If you want your caller of that method should be made aware, then you can actually go and report the error or throw the error from your method manually. Is it clear so far? Okay. Cool. Next, let's talk about the keywords that are used for the exception handling. What are the keywords that are used for exception handling? These are the keywords. One is try, another is catch, another is throw, another, the fourth one is throws, and then finally. Only these are the keywords involved in exception handling. Okay, nothing else. Okay, now so how should we write? How should we write that? The structure has been is getting mentioned here. The program statement that you want to monitor for exceptions. Okay. The program statement that you want to monitor for exception. Correct. You would put that inside the try. The program statements that you want to monitor for exceptions, you would put inside the try block. We call it as try block. Okay. Now, if exception occurs within the code which you are monitoring, it will be thrown from that block. So it will be thrown from this line. Imagine at this line, there is some exception that has occurred. It will be thrown right from this block and it will reach here. Okay. It will reach here at the end of the try. Clear? It will be thrown. Now, my code or your right, so the whoever is writing this try block, it can catch this exception using catch and handle it in a rational manner. So what we are saying is this try can catch the exception. So there may be a catch block, and it can catch the exception that is being thrown from the block that we are monitoring, the block of code that we are monitoring, and catch can handle it in a graceful manner, in a rational manner. Correct? Now, any system generated exception, that means the exceptions that were generated by the Java runtime system, are automatically thrown by the Java runtime system, that we already understood. So what it says is that the program statement that you are gonna that you want to monitor, put that within the try. Then if there is some exception that happens, that will be thrown from the block that you are monitoring to the end of the end curly braces of the try block. Keep that in mind, end curly braces of the try block, it will be thrown to. Correct? If that happens, now the control will come back to the end of the try block. If there is some matching exception that exists, okay, matching exceptions that exist for catch, right, then only the code that is there, the matching exception code, that will actually handle the exception gracefully. Okay, now that's it. So this is where our catch block is. Now we will also see where the throw is coming, where throws is coming, and where finally is coming. So at least we understood what should go inside try, what should go inside catch, and that's it. Clear? Yes. Now let's go back to the throw part. Whenever we want to throw the exceptions manually, we are going to use the throw keyword. All right. So imagine somewhere from the our program, I want to throw exceptions. So how the exceptions needs to be thrown? We know that exception is an object. So I need to create that corresponding exception object. So I can maybe throw, if I have to throw, let's say, imagine I have to throw some runtime exception. I can go and do it like exception, and then within that I can pass on the cause that, okay, something, right, whatever is the reason, I'm gonna pass that message, you are gonna type in your message, and that's it. So what we did, throw, and I have to throw the exception. Now we know that exception is an object, and that's why object is created using new keyword. I'm gonna use that to throw that. Okay, so we also got the uses of throw keyword. Now this keyword can be added anywhere within your method. You can, wherever you found that, okay, during execution, some exceptional behavior has happened in your method, and you want your caller to be made aware of it. So you can actually, if some condition has met, you can actually throw that exception using this statement. Clear? Now, that's what it says. An exception thrown from a method must be specified with throws clause, or right on the or alongside, along the method signature. So what we are saying is, imagine you are writing some void, you're writing some SAM method. Let's say this is my SAM method, and from within this SAM method, if let's say you are doing throw new runtime exception, what you can do is you have to actually declare. Now runtime exception, you can say this is the bad example for now because I haven't introduced you to other exceptions. So let's take some other exception name here. That's completely okay. So imagine I have created some custom exception, or I could have used the exception itself. So that needs to be declared at this portion. The portion is at this portion, it needs to be declared along with the method signature. I can say that, hey, this SAM method actually throws custom exception. Okay, all of us are aware of it. Clear? No issues. Yes, yes, yes. Clear? Now, Then there is finally block. It says that any code that must be executed after a try block completes needs to be put within the finally block. Now, let's get back to this. So in the try block, we know that the statement that we want to test needs to be put within the try block. Now imagine at this line, exception has occurred, and after that, at this line exception has occurred, and there are some lines that were written here. Now if I want such lines that irrespective of whether exception has occurred or not, I want them to be necessarily executed, I need to go and put them into the different block that is called as finally. Okay, now finally block has to come after try block. Along with try block, I cannot actually use the finally block independently. Similarly, catch block needs to come only after try block. I cannot use the catch block independently. But the same does not hold true for try block. We'll go and see that, okay, because there has been a new changes that was introduced, but this is what traditional try catch finally looks, that okay, any piece of code that must get executed needs to be put in here. This is must get executed will be put here, executed, right? Now, let's take a look at the general syntax. The general syntax, I talked about it. Within the try, the block of code that we want to monitor. Then within the after try block ends, we are adding catch, and there will be exception types, and I can have multiple catch block. Okay, this is like multiple catch blocks. Okay, but finally is right. Finally is again the single one. I cannot have more than one finally one. Okay, so catch is like you can have multiple catch block for a particular try block. Okay, so what we got is try block. We got different catch block, like one for exception type 1, another for exception type 2, and then maybe some more catch block if needed. But after that, there has to be some finally block. Sorry, we can put some finally block if I want some piece of code that needs to be always executed after my try block. Okay, so that needs to be put within this, right? It should be clear so far. Now, there is another syntax that is introduced that is called as try with resources. Try with resources. Okay, so traditionally what we see generally in the finally block, what we see is that uh, we actually used to do the closure of some of the resources or cleanup of some of the resources. Okay, so that's what traditionally all the Java programmers have been doing. That okay, hey, imagine I'm trying to write a piece of code which connects to, let's say, database. So database connectivity, anytime connection can fail. So that's why we should put them into the try block, and hence after that the connections are established, I'm gonna use that connection for further reading, writing, whatever we want to do. And at the end of it, I also want to close that connection. So that closure needs to happen even if while reading or after reading, during processing, there is some other type of exception happen, there is some other unusual behavior happen. Still with that, still even after that, I want my connection to be closed. Otherwise what will happen, my connection will remain open, and correspondingly for databases also there will be one connections remain open corresponding to this one that we established from our code. So that we do not want. We do not want to leak the resources, and that's the practice that people have been following, that in finally block generally cleanup of resources or closure, right? Closure of some of the, imagine you have opened a file to read. So you will ensure that once your reading is complete, you want the file to be closed. Same for write. So what happens is either you put the cleanup code or the closure of other resources in your finally block. So that's where there was an enhancement that was introduced. It is called as try with resources, the syntax is after try, there is a parenthesis and that needs to be added. And within that parenthesis, I can have a single or multi-line statement, single or multi-line statements. And what these statements should generally be, this should generally the creation of resources we should be doing here. So that's why it says, that's why this is also named as try with resources, because any resource that you want them to be kind of cleaned up properly, closed properly, you should put them within the try with resources, so that your JVM will guarantee that those resources are actually closed, even if something happens, something goes wrong, even after that your connections or your resources will be closed. So actually, try with resources, single or multiple statements can be added, and generally creation of resources. Now the question is, can I put all type of resources within this try with resources? The answer is no. I should only be putting auto closable resources. Auto closable resources. So what are auto closable resources? So auto closable actually is an interface that just have the close method, okay, that is declared. So if your resource has, or your class has, close method that is declared, then such resources can be used in try with resources. Is it clear? Is it clear? Yes? Yes. Now remaining syntax are optional. I can actually put catch blocks if I want to handle some of the exceptional behavior, or uh, the same time I can add the finally block, or I have choices that I can just use try with resources without any catch or finally. So actually with in try with resources, I can also use something like try uh, and then I can still use the finally block. That is completely okay. In fact, in the previous generic syntax, also I can use try and then finally. That is also fine. Yes, agree? Are you all agreeing with me? Yes. Is this true? Does this hold true? Yes, no.
Um, why this will happen? Like try, then the catch is not there, then finally.
Uh, are you asking, so in what scenario this can be?
Yeah, like what's the significance of doing like this?
Okay. So imagine I'm making a method call. I'm making a method call, and I know it may throw some error, but I do not want to handle this exception. I do not want to, or I do not have a right way to handle this exception. What I can do is I can just keep the finally block, and still I want to do the cleanup of resources. I can do the finally block, and because whatever exceptions that this may throw, this again needs to be declared with the throws keyword of my method. So if my method is again Sam, so it needs to be put that exception, okay, that may arise. And by doing this, what we ensured is that I just have to go and do the cleanup of resources that I initialized, but I do not want to handle the exception. That's it. That's the simple answer. Okay. But I would say practically people do not use it, but syntactically this is correct. Okay.
Yeah, one more thing, why try with resources? Like we can close the resources there in finally also, right? And even with this try with resources also we can use finally.
Yes,
Then
that is there. That is there. So it's like, imagine there are resources. So cleanup is not just the close part, right? There are resources. For example, the executor service, when it originally came, they had a mandatory method like call the shutdown, correct? So shutdown is not the close, although they got this limitations recovered. So originally executor service could not be used with the try with resources. So cases when in cases when Um, okay. In cases when your resources do not have or do not implement the close method, in that case, you should have your own handling, and that's why this finally block is still allowed. Okay, so the resources which are not auto closable, they should not be put, because their Java syntax is that something that you have put as a resource that must follow the auto closable, so that they will call, actually they will call the close part right after this they actually is gonna call the close part. Okay, so that's why they said that, okay, uh, whatever resources that you are going to use, they should be try with resources. Okay, they should be actually auto closable. Did I answer?
Yes, yes, sir.
Okay.
Got it. Yeah.
All right, so then let's talk about the exception type. What are the different type of exceptions? So the base class is throwable. Throwable is the base class of exception hierarchy. Then there comes the exception, and the another part is the error class. Okay, so throwable has two child, exception and error, and error exception has a different child, but one of our interest, or where we should pay attention, more close attention, is the runtime exception. Okay, so why it is needed, we'll come to that, but for now assume that exception has more hierarchies, but things to focus is on about the runtime exception. Okay, and there are a separate hierarchy for errors. Okay, so what exactly are errors? So errors are used by runtime system to indicate errors of itself. If some error has happened within the JVM, so those classes, those exceptions will be thrown from the JVM to your method. Okay, so again, JVM uses this class of hierarchy. We did not be using it. Okay. And the question is again, this is not advisable to catch the error. Okay. So because these errors as well as the runtime exceptions, they too are part of the, unchecked exception. Okay. Unchecked exception. So what is checked versus unchecked? We'll come to that. But for now, you consider it as your runtime exception and the error hierarchy. Both of them are part of unchecked exception. Okay. And all other exception classes are the checked exception. All other classes are exception hierarchy classes are the checked exception. Is it clear? And that's where people do not advise to actually catch the throwable. That's where people do not advise that, okay, unless you have a specific way of getting out of that error situation, you should not go and basically catch the throwable. But yeah, there are scenarios, there are certain type of errors that we want to control, that we want to catch. So in that case, people do that. Okay. Is it clear? Is it clear? Now, checked versus unchecked exceptions. So there are two type of exceptions, that is checked and another is unchecked. Okay. Now, why these two types are there? So in Java, exception handling, whether you have handled your exceptions or you have thrown the exceptions, this checking is done at the compile time. This checking of whether you have declared your exceptions or you have handled it gracefully, either declare or handle, right? So the checking happens at the compile time, and the checking happens only for the exception classes which are unchecked exceptions. So apart from this and this, if your method declares that, okay, or if from your method you throws exception of type exception, like if you throws new throw, you make it like throw new exception. So what you need to do is your method signature should explicitly declare that you are throwing the exception. Okay, so you are throwing the exception that you must declare. Okay, otherwise you will get the compilation error. Now, is it clear? Okay with me? Checked versus what is checked exception. So all the classes that is sub hierarchy of runtime exception or error, they form the, sorry, they are the unchecked exceptions remaining, right, except the runtime exception and error. All other classes or other exception classes are actually part of the checked exception. Checked means it, the syntax will be checked during compile time, whether the caller of a method has handled it or it has declared it. So it has two choices. A method is either handling the exception or it is declaring that, okay, I'm going to throw it again. Okay, so that's the two choices, and these two choices needs to be implemented. This will check during your entire program and during compilation. So in your program, if you have followed the rule that, okay, you have declared, sorry, handled all the checked exceptions and you have declared wherever necessary, then you are done. You will not get any compilation error. But if you haven't followed that rule, you will right away get the compilation error. Okay.